Some nights you look up at the sky and see a faint band of light stretched across the darkness. It appears quiet, distant, almost motionless. But the truth is this: you are looking at a colossal cosmic machine in constant motion, the Milky Way, our home. Here is the problem. We live inside the Milky Way, yet we understand it very little. We call it our galaxy, but we rarely pause to ask, how large is it? How old is it? What is it made of? And where is it going? Most of what makes up the Milky Way is invisible. Dark matter, cold gas, gravity, and collision histories that time has concealed. This video does not promise to turn you into an astronomer. What we offer is 100 carefully selected facts, enough for you to see the Milky Way with different eyes, deeper, slower, and clearer. You will learn why this home is not quiet at all, why one orbit of the Sun takes hundreds of millions of years, and why, in every breath you take, there are still traces of stars that died long ago. Relax. The Milky Way is still turning, and its story is only just beginning. When we talk about the Milky Way, natural intuition often leads us to the image of a sturdy home, a giant, stable spiral where the Sun and Earth quietly circle like clock hands inside an orderly machine. But that is only the illusion of familiarity. What modern astronomy reveals is entirely different. The Milky Way is not a static roof over our heads, but a violently evolving structure, built through collisions, swallowing, and constant restructuring across billions of years. Understanding this does not only change how we see the galaxy, it changes how we see our own place in the universe. First, we must break a fundamental misconception. Galaxies are not immutable islands of stars. In modern cosmology, galaxies grow in a way that closely resembles the history of ancient empires. They expand by absorption. The Milky Way has been, and still is, eating smaller galaxies, drawing them into its gravity, tearing apart their original structures and stretching their stars into thin, long stellar tidal streams. A vivid example, almost unfolding before our eyes, is the Sagittarius dwarf spheroidal galaxy. This dwarf galaxy is currently being shredded by the Milky Way. With each orbit, more of its stars are pulled from its original body, forming luminous bands that wrap around the Milky Way's disk like glowing scars. What is striking is that these scars do not vanish. They persist for a very long time in the Milky Way's halo, becoming historical evidence of past acts of galactic cannibalism. Thanks to missions like Gaia, astronomers can not only see the shapes of these stellar streams, but also read their kinematic memory, their orbits, velocities, and inclinations. Each stream is an old story, written not in words, but in motion. This makes the Milky Way feel like a moving museum of history, where the past does not lie still, but continues to rotate alongside the present. But the story does not end with dwarf galaxies. In the distant future, the Milky Way is headed toward a far grander encounter, the Andromeda Galaxy. At present, Andromeda is moving toward us at a speed of about 110 kilometers per second. That number may sound modest, but on cosmic timescales, it is an appointment that cannot be avoided. About 4.5 billion years from now, the two giant spirals will begin to merge in an event scientists call a galactic merger. When people hear collision, they often imagine a violent catastrophe. Yet, paradoxically, in galactic mergers, stars almost never collide directly. The distances between stars are so vast that most simply pass by one another, while the overall shapes of the galaxies are dramatically distorted by gravity. The result will be a slow dance. Spiral arms stretched into enormous tidal tails, galactic cores oscillating, and finally, after billions of years, the two systems settling into a new structure, perhaps a giant elliptical galaxy. This emphasizes an important truth. The shape we see today is only one frame in the Milky Way's very long film. There is no standard or eternal form, only temporary states of a system continually adapting to the gravitational interactions around it. From a human perspective, this brings a feeling both humbling and profound. We tend to attach the idea of home to stability and safety, yet our galactic home is built from the ruins of other homes. The elements in Earth, in the human body, may once have belonged to stars in dwarf galaxies swallowed long ago. As Carl Sagan wrote in Cosmos, we are made of star stuff. Placed in the context of galactic mergers, that line gains an even broader meaning. We are made not only of stars, but of the collision history of an entire galaxy. Science also shows that these mergers do not only destroy, they stimulate creation. When galaxies collide, gas and dust are compressed, triggering bursts of star formation. In other words, the end of one structure opens the beginning of millions of new stars. In this view, the Milky Way is not a cold destroyer, but a gravitational ecosystem where destruction and creation are inseparable. That is why, when we say the Milky Way is a home that is not still, we are not only describing a physical fact, we are touching a philosophical truth. There is no absolute stability in the universe. Every large structure is built from change and exists only through its ability to adapt to that change. Stephen Hawking emphasized this spirit when he said, "The universe doesn't allow perfection. Imperfection, collisions, distortions, accumulated scars is what makes history." Finally, when we look at the Milky Way's pale band across the night sky, its peaceful appearance is no longer a sign of stillness, but a thin surface hiding a violent past. The Milky Way is not a house that was built and then left unchanged. It is a construction site still at work, where gravity continues to pull, tear, and reshape at every moment. And within that construction, we are not merely temporary residents. We are part of the material itself, carrying the memory of ancient collisions and moving toward encounters that have not yet happened. After realizing that the Milky Way is a home that is not still, built through collisions and swallowing across billions of years, the story naturally leads us to the silent witnesses of that past, the galaxy's elders. If tidal stellar streams are bright scars of mergers, then metal-poor ancient stars are the deepest memory, settled in the halo, the region that envelops the Milky Way's luminous disk like an ancient shadow. There, history is told not by shape, but by chemistry, and the slow motion of stars that survived from the universe's dawn. In astronomy, the word metals has a special meaning, every element heavier than helium. The early universe, right after the Big Bang, contained almost only hydrogen and helium. Heavier elements, carbon, oxygen, iron, calcium, appeared later, forged in stellar cores and scattered into space by supernovae. Therefore, a star's metal content becomes a measure of time. The poorer a star is in metals, the more likely it formed early, before many generations of stars enriched the interstellar environment. This is the foundation of what is called a chemical fingerprint. Each star carries a birth record, preserving the conditions of the environment in which it formed. These elders often reside in the halo or the thick disk, moving on inclined, elongated orbits, sometimes even opposite to the general rotation of the thin disk. They do not follow the tidy order of young stars in the bright disk. They resemble ancient wanderers, roaming at the edges of structure. Many of them may have formed before the Milky Way was fully assembled, when our galaxy was still a loose collection of gas, dust, and proto-galactic fragments gradually merging. Others arrive from primitive galaxies the Milky Way swallowed, carrying the chemical memory of a different environment, a different history. What gives chemical methods their power is not only age, but origin. Two stars may be equally old, yet different elemental fingerprints tell different stories. The ratio of alpha elements, such as magnesium and silicon, to iron, for example, reveals the star formation tempo of the original environment, rapid or slow, burst-like or prolonged. With this, astronomers can group stars into families, trace the remnants of dissolved dwarf galaxies, and reconstruct the Milky Way's merger map across time. It is a special kind of archaeology, not digging into soil, but reading light. There is a quiet beauty in this idea. Ancient stars do not show off. They are dim, cool, and slow. Yet that humility is precisely what makes them reliable witnesses. As large structures warp and spiral disks are stretched and reshaped, the chemistry remains steadfast, truthful. As an astronomer once observed, reading stellar chemistry is like reading old poetry. Each line may be difficult, but when assembled, an entire era appears. At a deeper level, the galaxy's elders raise a subtle philosophical question. How do we measure time? For humans, history is text, artifacts, collective memory. For the universe, history lives in spectra. A faint absorption line of iron can say that a star was born when the universe was young. A lack of carbon can suggest it came from a metal-poor dwarf galaxy. Time here does not flow in calendar years, but in cycles of star birth and star death. The presence of ancient stars also reminds us that the Milky Way does not have a single birth moment. It formed gradually, patched together, absorbing, restructuring. Each ancient star is a fragment of that picture, and when enough fragments are assembled, we see a history that is not linear, but full of breaks and convergences. This fits the spirit of modern science. Evolution is not a straight line, but a network of possibilities. Carl Sagan wrote, "We are a way for the cosmos to know itself." Placed beside the galaxy's elders, that sentence gains a new depth. For it is through them, nearly nameless stars, quietly on the edge of the light, that the universe tells its story back to itself. They allow us to know how simple the universe once was, how poor it once seemed, and how, through long cycles of creation and destruction, it became as rich as it is today. Connecting back to the earlier thread, if collisions are the engine that made the Milky Way grow, then ancient stars are the evidence that this growth has memory. They do not only say, "This happened," but "This is how it happened." And in the halo's quiet, among inclined orbits and faint light, these elders continue their work, keeping time, so that when humans look up, we can understand that our home is not only vast, but very old. So old that its memory is carved into every atom of light. After listening to the story of the elders in the halo, stars that hold the chemical memory of the universe's dawn, the narrative naturally flows into another dimension of time, galactic time. If ancient stars tell us what the universe once was, then the solar system's orbit around the Milky Way's center lets us feel how time operates when every human scale becomes far too short. Here, history is not counted in years or centuries, but in a single orbit longer than entire eras of life. The solar system is racing through space at about 230 kilometers per second, a number that makes imagination hesitate. Yet the paradox is this: even at such a speed, we still need roughly 225 million years to complete one galactic year, one orbit around the Milky Way's center. In that time, continents drift, climates transform, species appear and vanish. The entire evolutionary story of life on Earth occupies only a thin slice of that endless path. Measured this way, the human sense of long and fast suddenly feels fragile. Placed within that orbit, we discover a truth both humbling and profound. Life is a short-term guest within a very long motion. Since the solar system formed, it has completed only about 20 orbits around the Milky Way. The last time we passed through a similar region of space on our current path, Earth was in a completely different state. Complex life had not yet taken shape. The atmosphere, the oceans, even the continents did not resemble today. Galactic time, therefore, is not only long, it dissolves our intuition about permanence. What is striking is that there is no galactic clock ticking aloud. The orbit unfolds in silence, governed by gravity and the mass distribution of the entire galaxy, from luminous stars and gas and dust to invisible dark matter. Each star has its own orbit. Not all motion is perfectly circular or perfectly regular. Some stars move ahead, some fall behind, some bounce above and below the disk's plane. And yet the whole maintains a stable flow, resilient enough for large structures to persist for billions of years. It is dynamic stability, not stillness, but balance in motion. Here, galactic time gives us a quiet, philosophical lesson. We measure time by repetition, day and night, seasons and years, generations and eras. But for the Milky Way, that repetition is too slow to feel. A galactic year is so long that the entire history of human civilization is only a thin stroke in the orbit's diary. This does not make humanity small in a pessimistic way. Rather, it offers a new perspective. Meaning does not lie in the length of existence, but in the depth of awareness within the time we are given. Life on Earth, fragile, brief, has flourished while the solar system silently traveled a small fraction of its orbit. This shows that galactic time does not oppose life. It provides the frame in which life unfolds. Bursts of star formation, passages through dust-rich regions, quieter eras at the edges of spiral arms, all leave indirect traces in Earth's environment. But these traces are not destiny. They are conditions, not a predetermined script. Life learned to adapt, evolve, and write its own story in the spaces between orbits. A physicist once said, "Time is what keeps everything from happening at once." John Archibald Wheeler. In the galactic context, the line becomes strangely concrete. If everything happened at once, there would be no evolution. If the orbit were too fast, there would be no memory. If too slow, there would be no change. Galactic time, long, steady, quiet, is what allows complexity to accumulate. It allows stars to be born and die, allows heavy elements to form, allows planets to cool, and finally allows biology to take root. At a deeper level, that 225 million-year orbit also shakes the human sense of centrality. We are not standing still while the universe turns around us. We are moving with the universe. Every moment, even in sleep, the solar system continues to drift through new regions of space. As Carl Sagan reminded us, somewhere, something incredible is waiting to be known. That waiting is not a promise of spectacle, but an invitation to patience. The deepest truths often reveal themselves on very long timescales. Connecting back to the previous section, if ancient stars show us the Milky Way's memory, then galactic time shows us the breathing of that memory. Memory does not stand still, it moves with orbit. And in that movement, Earth, a small blue dot, has had time to form oceans, life, and consciousness. Not because we are fast, but because the universe is slow enough for it to happen. Finally, when we think about a galactic year, we are no longer haunted by the shortness of human life. Instead, we are gently comforted by a quiet truth. We belong to a very long motion. Even if a human lifetime is a moment, that moment unfolds within a vast orbit, wide enough to hold the memory of ancient stars and slow enough to nurture life. The Milky Way is not in a hurry, and it is precisely in that unhurriedness that human beings have had the time to look up and understand that we are traveling with the universe, not being left behind. After feeling the rhythm of galactic time, an orbit lasting hundreds of millions of years that makes the history of life seem fragile, the narrative opens onto an even more unsettling truth. The Milky Way has never been a finished entity. If time tells us how long the universe has been running, then growth tells us what the universe is doing right now. The Milky Way does not merely exist, it is growing, quietly, continuously, and without asking permission from human intuition. First, we must discard a common illusion that galaxies are stable structures completed early on. In reality, the Milky Way is an open system. It is still drawing in gas from the intergalactic medium, matter so thin it is nearly invisible, yet sufficient to sustain star formation for billions of years. These gas flows do not arrive in floods. They seep in like night mist, slowly replenishing the galactic disk. Without them, the Milky Way would have aged far faster, running out of fuel and dimming as its stellar furnaces died down. But gas is not the only thing being accumulated. The Milky Way also captures stars, cosmic migrants from less fortunate dwarf galaxies. When a small galaxy passes too close, gravity tears it into long streams of stars, stretching tens or hundreds of thousands of light years. Those stars do not disappear. They are resettled into the halo and thick disk, becoming part of a larger structure. On this scale, eating does not mean instant destruction, but dissolution, a long, quiet process that leaves traces in stellar motion and chemistry. Behind all these visible motions lies an invisible but decisive agent, dark matter. Though it emits no light, reflects none, and absorbs none, dark matter feeds the halo, the gravitational cocoon surrounding the entire galaxy. The halo does not merely keep stars from flying away as the galaxy's edge rotates too fast. It also shapes how the Milky Way grows. Simulations show that intergalactic gas often slides in along the filaments of the cosmic web, guided by the halo's gravitational field. In other words, the Milky Way's future shape is being sketched by something we cannot see. This leads to an important consequence. The Milky Way today is not the Milky Way of the dinosaurs. When dinosaurs walked the Earth, our galaxy had a different structure, different star formation rates, different gas distribution, and even the solar system's orbit was not at the same position. Since then, the Milky Way has changed its skim, absorbing more stars, accumulating more gas, and adjusting the disk's shape through gravitational interactions. These changes do not shock Earth, but they form the quiet backdrop to planetary history. Looking into the future, the story becomes even more open. The Andromeda galaxy is drawing nearer, and in a few billion years, the two galaxies will merge. This event is not the end of the Milky Way, but a new chapter, a bolder phase of growth, where the halo swells, gas is stirred, and new generations of stars are triggered. The post-merger galaxy will be larger, heavier, and utterly unlike our current picture. If there are observers then, they will not speak of the Milky Way as we know it today, but of a successor. Here, science touches philosophy. We often ask, what is the universe? But the growth of galaxies forces a different question. What is the universe becoming? There is no fixed final state. As the astronomer Edwin Hubble wrote, equipped with his 5 senses, man explores the universe around him and calls the adventure science. That adventure is not meant to find a stopping point, but to keep pace with change. The Milky Way's unfinished nature is also a reminder of humility. The beautiful models of today, spiral disks, balanced halos, are only snapshots of a moment. Tomorrow, with better data, we will see new gas streams, new satellites, new irregularities in stellar motion. And each time, the story will be rewritten, not because science was wrong, but because the galaxy continues to grow. Connecting to the earlier section on galactic time, we see that growth and time are two faces of the same reality. Long time allows slow growth. Slow growth gives time meaning. Within that frame, life on Earth appears, evolves, and may vanish, while the Milky Way continues to accumulate each grain of gas, each star, each unit of invisible mass. As Carl Sagan reminded us, we are a way for the cosmos to know itself. If that is true, then understanding that our galaxy is still growing is the way the universe, through us, recognizes its own openness. In the end, an unfinished story is not a complaint, but an invitation. An invitation to observe, to measure, and to accept that our home is not a quiet museum, but a cosmic construction site operating for billions of years. The Milky Way will continue to change after we are gone. Yet in this present moment, when we look up and understand that it is still growing, we become part of that story, even if only a small footnote in the endless chronicle of the universe. After seeing the Milky Way as an entity still growing, never completed, the narrative naturally leads us deeper. The structure of this home is not as neat as the textbook illustrations. When observational technology becomes precise enough and data becomes dense enough, the Milky Way appears not as a perfect spiral disk, but as a body with folds, distortions, and the traces of ancient violence. These oddities are not measurement errors. They are living records of the galaxy's chaotic evolution. First is a seemingly simple question. How many spiral arms does the Milky Way have? It sounds paradoxical to say we are not certain about this for our own galaxy, but it is scientific truth. The problem lies in our vantage point. We are not outside looking in, we are stuck inside the disk, amid thick cosmic dust that blocks visible light. Spiral arms are not rigid arms, but density patterns where gas is compressed and young stars flare to life. Depending on the observing wavelength, infrared, radio, or visible light, the structure looks different. At times, scientists believed in 4 main arms, then leaned toward 2 major arms with smaller branches. This ambiguity does not simply reflect ignorance. It shows that the Milky Way is a dynamic structure, not frozen into a single shape. That imperfection becomes even clearer in the warped disk. If the Milky Way were a flat disk, observations would not contradict it so strongly. But radio telescopes tracking neutral hydrogen gas, HI, reveal the galactic disk like a sheet of silk bent out of plane, one side lifting, the other sagging. This warp is not small, and it cannot be explained as noise. Current hypotheses suggest it is the result of gravitational interactions, pulls from satellite galaxies, an asymmetric dark matter halo, or infalling intergalactic gas. The key point is this: the warp proves the Milky Way is not in static equilibrium. It is being pulled, twisted, reshaped right now. From large structure, the story turns to the galaxy's most rebellious individuals. Hypervelocity stars, runaway stars. Most stars are bound by the Milky Way's gravity, but a rare few reach speeds high enough to escape the galaxy entirely. The most common mechanism involves the galactic center, home to Sagittarius A star, the supermassive black hole. When a binary star system passes too close, one star may be captured or swallowed, while the other is flung outward like a gravitational bullet, racing away at hundreds, even thousands of kilometers per second. These runaway stars are living proof that the Milky Way evolves not only through accumulation, but also through loss. Not only are some stars ejected, some also move in the opposite direction, on retrograde orbits, against the general rotation of the disk. In a single, isolated formation scenario, this would be rare. Therefore, retrograde orbits are considered fossil traces of the Milky Way's ingestion of dwarf galaxies. When an external star system is absorbed, its stars do not immediately blend into the common flow. They retain their old orbits, like a kinematic memory of a different origin. Each retrograde star is a migration story, evidence that the Milky Way is built from many pieces. One of the largest such pieces discovered in recent decades is Gaia Enceladus. Thanks to the Gaia mission's precise data, astronomers identified a population of stars with unusual motion and chemical composition, the remnants of a large dwarf galaxy that collided and merged with the Milky Way about 8 to 11 billion years ago. This event did not only add stars to the halo, it also shaped the giga. It shaped the thick disk, heated stellar orbits, and altered the overall structure. The Milky Way today, with its extended halo and layered disk, bears the direct imprint of this act of cannibalism. The common thread in all these phenomena, ambiguous spiral arms, a warped disk, runaway stars, retrograde orbits, and the legacy of Gaia Enceladus, is that they break the image of ideal order. They force science to accept that galaxies are the products of prolonged instability, not perfect design. As the physicist Richard Feynman said, "I think it's much more interesting to live not knowing than to have answers which might be wrong." It is precisely this messiness that makes the Milky Way more scientific not less. These structural oddities also function as a map of time. Every warp, every skewed orbit, every accelerated star is a historical marker. They let us read the past without reversing time. Connected back to the previous section, where the Milky Way is still growing, we see that growth does not happen smoothly. It comes with structural upheaval, with consequences that remain for billions of years. The galaxy's present is the sum of countless events in the past. At an even deeper level, these structural mysteries carry philosophical meaning. They remind us that stability is only a local feeling. On cosmic scales, every structure is temporary. Every order can be bent. The Milky Way, our home, is not a quiet, unchanging place, but a gravitational flow where stars can be born, flung away, or pulled against the current of history. Placed in that context, the human emotion is not anxiety, but humility. We live in a galaxy filled with scars and folds, and that is exactly what makes it alive. Each time science discovers a new structural irregularity, it is not a crisis of models, but the opening of a new chapter. The Milky Way does not promise simplicity. It offers only an invitation. Look closely at what does not fit, because that is where the universe's history speaks most clearly. After passing through the Milky Way's folds, distortions, and collision memories, the story naturally reaches its deepest layer. The things we cannot see, yet that decide everything. If spiral arms, a warped disk, or runaway stars are outward expressions of chaotic history, then dark matter and the galactic center are the silent framework that prevents the whole structure from falling apart. Here, science relies less on direct imagery and more on inference, traces, and consequences. The story begins with a classic paradox. When astronomers measured the rotation speeds of stars at the Milky Way's outskirts, they found something unacceptable under Newtonian mechanics. Distant stars rotate almost as fast as those near the center. By calculations based only on visible matter, stars, gas, dust, the galaxy's edges should rotate far more slowly, or even be flung into intergalactic space. Yet the Milky Way remains intact, not because our measurements are wrong, but because we are missing something. That missing something is called by a name both simple and unsettling: dark matter. It emits no light, reflects none, absorbs none. It does not appear in telescopes, but it creates gravity, and that gravity is strong enough to hold an entire galaxy together. Dark matter forms an enormous halo, wrapping the Milky Way like an invisible skeleton. The luminous disk we can see, every star, nebula, planet, is only a thin skin inside a structure many times more massive. The crucial point is this: we know dark matter exists not because we see it, but because without it, the universe collapses mathematically. As the astronomer Vera Rubin said when describing her discovery of galactic rotation curves, "What you see is not what you get." That sentence applies not only to the Milky Way, but to the entire universe. Most of reality does not shine, does not display itself, yet it governs all motion. From that invisible skeleton, the narrative moves toward the darkest heart of the galaxy. At the Milky Way's center, about 26,000 light-years from us, there exists a presence both silent and overwhelming: Sagittarius A star. This is a supermassive black hole, about 4 million times the mass of the Sun, compressed into a region of space smaller than Mercury's orbit. We do not see it directly, but we see the stars around it moving, so fast that only an extraordinarily strong gravitational field can explain them. What makes Sagittarius A star special is not only its mass, but its current quietness. It is in a sleeping state, not swallowing matter at a high rate, not blasting out fierce radiation like distant quasars. But indirect evidence, such as the enormous gamma-ray bubbles stretching tens of thousands of light-years above and below the galactic plane, suggests that in the past, Sagittarius A star may have awakened star. It may have flared, releasing energy great enough to affect the entire central region. The astrophysicist Kip Thorne wrote, "Black holes are where God divided by zero." The line is not merely poetic. Black holes represent the limits of understanding, where familiar laws begin to crack. That a relatively calm spiral galaxy like the Milky Way carries such a black hole at its heart is a philosophical paradox. Long-term stability is anchored by an extreme point. Surrounding Sagittarius A star is the central bulge, and surprisingly, it is not round. When astronomers observe the Milky Way in infrared and map stellar kinematics, they find the bulge shaped like a peanut or an X when viewed edge-on. This is not decoration. It is a trace of long-term dynamics. The shape is directly tied to the central bar, a long, slowly rotating stellar structure that has existed for billions of years. The bar acts like a distribution engine. It stirs stellar orbits, drives gas inward, feeds the galactic center, and may once have supplied Sagittarius A star with fuel during active phases. Over time, this collective motion puffs the bulge vertically, creating its characteristic peanut shape. In other words, the Milky Way's central form is the product of billions of years of shared motion, not a primordial structure. Linking back to the previous section, Structural Mysteries, we see a clear continuity. Ambiguous spiral arms, a warped disk, runaway stars, all depend on the invisible gravitational foundation of dark matter and the organizing influence of the center. Without a dark matter halo, the disk would not remain stable long enough to form spiral patterns. Without a massive center, stellar orbits would be different, the bar would not exist, and the bulge would not take its present form. The invisible is not peripheral, it is the main stage. Emotionally, this section leaves a particular resonance. It forces the listener to face an uncomfortable truth. Most of reality cannot be seen or touched, yet cannot be denied. We live in a galaxy whose majority of mass is mysterious. Its center is a region where time and space bend, and the billions of years' stability of this home depends on things humans have only begun to understand in the last few decades. As Carl Sagan wrote, "Somewhere, something incredible is waiting to be known." Dark matter and Sagittarius A star embody that line. They do not offer simple comfort. They offer intellectual humility. The Milky Way is held together not by what feels familiar, but by what lies beyond intuition. And as this part closes, the listener may feel something clearly. We do not live in a galaxy that is easy to understand. Yet that is exactly why it is worth exploring. In the darkness of dark matter and the silence of the central black hole, the Milky Way keeps turning, holding us within its gravitational embrace, an embrace invisible, yet astonishingly enduring. After reaching the invisible framework that keeps the Milky Way from falling apart, dark matter and the heart of a supermassive black hole, the story naturally turns toward a gentler yet equally profound direction. The places where the galaxy gives birth to life, and the places where it stores memory. If the previous section showed why the Milky Way exists, this section answers what the Milky Way remembers and what it is creating. Here, the galaxy appears as a complete ecosystem, where birth, death, storage occur at once, slowly and steadily across billions of years. The narrative opens with the cradles of light, giant molecular clouds, physically cold, dark and massive, yet enroll the source of every star. Within the Milky Way, clouds of molecular hydrogen and cosmic dust drift along spiral arms. When they enter the compression region of density waves, matter is squeezed, temperature and pressure rise, and gravitational collapse begins. From that cold darkness, young stars ignite. The bright blue of hot stars traces the curve of spiral arms, leading us to imagine spiral arms as fixed structures. In truth, they are birth paths. Stars are born, shine briefly, then move on, leaving a glow for the next generation. On an emotional level, the paradox is beautifully simple. The darkest places are where light begins. The astronomer Sir Arthur Eddington wrote, "We are bits of stellar matter that got cold by accident." The line is not only poetic, it reminds us that every atom in our bodies, carbon, oxygen, iron, once passed through stellar furnaces in clouds like these. When we look at star-forming nebulae, we are not only seeing the galaxy's future, we are also seeing the deep past of ourselves. From the active cradles, the narrative shifts toward the Milky Way's most enduring memories, the halo and globular clusters. If the galactic disk is where life moves quickly, stars form, die, and matter cycles, then the halo is the slow archive where time seems to flow differently. Globular clusters are dense, spherical groups of hundreds of thousands, even millions of stars, bound tightly by gravity, orbiting the galactic center on high, inclined paths. Most of them are very old, over 12 billion years, a metal poor, suggesting they formed when the universe was still young, before many generations of stars enriched the environment with heavy elements. For this reason, globular clusters are often called living fossils. They preserve what the galactic disk has lost, early chemical conditions. By studying the composition of stars in these clusters, astronomers can infer conditions in the early universe, even trace ancient dwarf galaxies that the Milky Way swallowed. As the astronomer David W. Hogg remarked, the stars remember. They remember through orbit, motion, and the elemental ratios in their atmospheres. The transition between birth and memory is not disjointed. It highlights the cycle. Stars form in molecular clouds, live, die, and release matter back into the interstellar medium. Part of that matter forms new stars in the disk, while another part is driven into the halo by supernovae and stellar winds, slowly enriching those ancient storage regions. The Milky Way does not only move forward, it continually converses with its own past. Here, the script gently reminds us of a humbling fact. What the naked eye sees is only a tiny slice. Under ideal skies, a human being can see a few thousand stars. That sounds like many, an ocean of light. But compared to the Milky Way's more than 100 billion stars, it is only a drop. Most stars are hidden by dust, too dim, or outside the human eye's sensitivity. The galactic reality we intuitively feel is a simplified version of a far larger ecosystem. Carl Sagan emphasized this in Cosmos. The universe is not required to be in perfect harmony with human ambition. Applied to the Milky Way, the line reminds us that our understanding is always limited by our position and our senses. We live within the disk, looking sideways through dust and gas. We do not have a top-down view. So every star map, every structural model is the product of patient inference, not direct observation. The link from the invisible skeleton to the cradle and memory becomes natural. Dark matter creates the gravitational stage, the galactic center shapes dynamical rhythm, and molecular clouds and the halo are the living content unfolding on that stage. Without dark matter, clouds would struggle to remain stable long enough to form stars. Without a massive center and a history of collisions, the halo would not accumulate ancient clusters as a storage of time. The invisible supports the visible. What lives rests upon what remembers. At the final emotional level, this section closes with a deeply human realization. We are not only living in the Milky Way, we are the product of both sides, birth and memory. The elements in our blood come from star-forming nebulae. The stable existence of our planet comes from the halo's long history and the collisions that shaped the galaxy. The Milky Way, therefore, is not merely a physical location, but living time, a chronicle written in light, darkness, and slow motion. And as the listener grows still, perhaps they will feel something simple yet powerful. Within a galaxy too vast to imagine, we were born from its darkest cradles and sheltered by its oldest memories. The Milky Way does not only rotate, it nurtures and remembers. And within that rotation, human beings find both the source and the meaning of themselves. After the long journey through collisions, memory, birth, and the Milky Way's invisible structures, the conclusion naturally returns to human beings, not as observers standing outside, but as participants inside the story. If in earlier parts, we looked at the Milky Way as a vast physical system, here the galaxy becomes a home with human meaning, a place where life, consciousness, and memory meet. The passage from science to humanism is gentle, almost without a boundary. For science has led us to a simple truth. The elements in our blood were forged in the cores of ancient stars. The oxygen in every breath was released by distant supernovae long ago. We do not belong to the Milky Way as a metaphor. We were made from it in the most literal physical sense. As Carl Sagan wrote in Cosmos, we are made of star stuff. The line is not only beautiful, it is precise to a chilling degree, and for that very reason, deeply comforting. In the final rhythm, the story slows. There are no more enormous numbers, no more structural diagrams, only quiet motion. The galaxy still turns, stars are still born, light still travels across tens of thousands of light years, whether or not human beings pay attention. And within that flow, you are resting. Not separate, not lost, but held entirely inside it. This ending is not meant to make you feel small, but to make you feel that you belong. In a universe vast and sometimes hard to understand, the Milky Way is no longer a distant astronomical concept. It becomes a silent home, one where you can close your eyes, knowing you are lying still inside a story that began billions of years ago and is still continuing, very slowly, very steadily, together with you.